Good morning. I'm honored to be here at the Esri Geodesign Summit. It's been an inspiring couple days for me. Jack was right when he said we are on an unsustainable path. To address the world's greatest challenges, we all must help transform the world. I wanted to thank you all for the amazing work you do every day. Today, I wanted to share a little bit of EarthGenome's story, our focus on global water issues, and how we're tackling that in California. Along the way, I'm going to spend less time on the technical details, so I can share more about what we've learned and how that fits into the bigger picture. First, some background on the Earth Genome. We're an environmental data nonprofit co-founded by 3 people. Steve, who used to run the world's largest environmental NGO and then later ran the largest private funder of environmental conservation. Dan, who co-founded Global Forest Watch, was a leading data scientist for NASA and also worked in the White House Office of Science and Technology Policy. And myself, a former Bain & Company principal who now serves on the faculty at UC Berkeley, and I teach corporate environmental sustainability at the Haas School of Business. Widely different people, but with what Steve calls an alchemy that helps connect disparate issues that have long challenged the environmental movement. To highlight this challenge, I wanted to share a personal story. 10 years ago, I was a consultant working for Walmart, the world's largest company, to help launch the Sustainability Index. I was facilitating a full-day workshop with their top 30 merchants, who collectively buy over $200 billion of stuff every year. My goal, help them buy more sustainable products so they could help transform how the whole world buys and consumes our natural resources. But despite months of pre-work, the best we could do was highlight general trends. We all lack the specific information needed to make their purchasing decisions significantly more sustainable. It was an incredibly frustrating and humbling experience, but it taught me 2 things that we focused on in the Earth Genome. 1, some of the world's most impactful decision makers want to make better decisions, but they can't. And 2, when trying to solve intractable environmental issues, you're often better off focusing on the few people or places that can change a whole system. So now, I wanted to focus on global water challenges. Water is life's most essential ingredient. It touches each of our lives and humanity overall in so many ways. But today, water faces wicked challenges, in particular, the interrelated challenges of too little, too much, and too dirty. This recent headline article from the New York Times echoes what we already know throughout the world. Droughts and flood are the new normal, and this is affecting billions of people. Make no mistake, what we are doing today is not good enough. 2.1 billion people lack access to safe water. Over 2 billion people have been affected by flooding since '95. $114 billion more is needed annually to try and achieve SDG 6. The Forum's Global Risk Report, released last month, has the top 5 risks include water crises, extreme weather, and climate action failure. Today, there are way too many water problems and too few solutions. Why isn't this being solved? The United Nations Status Report on SDG 6 highlights 3 critical enablers that are needed desperately for greater progress. The first is data. Water resources management needs better data. Technology can effectively improve all aspects of water resources. And lastly, stakeholders. Multi-stakeholder partnerships can unlock potential. Sharing, accessing, and adapting solutions takes cooperation. In short, the world needs better water governance, and we need to bring data, technology, and stakeholders all together at an actionable level. Importantly, that view must be integrated into a system view consistent with integrated water resources management. Imagine stakeholders can see in a single interface. Oh, actually, it skipped over. Interesting. Groundwater and surface water, water quantity and quality, and see how they are related. Across both urban and rural watersheds, within and across jurisdictions and boundaries. Historical trends and, where possible, future predictions. Unfortunately, this view isn't available today in any basin in the world. Fortunately, technology like GIS can help us achieve exactly that. The key is that GIS enables us to see across spatial scales and temporal scales. It helps solve the critical where and when issue related with water. And scale isn't just variables like X, Y, Z, and T, but instead scale impact. GIS helps us be replicable, extensible, and repeatable. In short, scalable. In my opinion, the world cannot solve global water challenges without GIS. We need scalable tools built once and deployable everywhere. Focus not just on global risk, but on implementing actual solutions that are known to work in a local environment but haven't been sufficiently scaled. That is what ArcGIS is working toward across a suite of place-based projects with explicit decision makers now underway in multiple different geographies. We are working to build that integrated view, leveraging GIS to help key decision makers to game these extremes. So now I'm going to focus specifically on our water work in California to illustrate how we're tackling the problem across multiple scales. California is a unique place. Largest state in America at 40 million people, and the 5th largest economy in the world based on GDP. Unfortunately, California has some of the nation's toughest water challenges. Most notably, it really illustrates the where and when issue related to water. It also faces the common issue of competing demands for water. Since I was born in California, the population has doubled. Having said that, today, more water is used to grow almonds in California than all current residents combined. Perhaps what California has most in common with other places are droughts and floods. Just recently, we had 4 years of historic drought, followed by the second wettest year on record. But perhaps this is where the California story takes an unexpected twist. Many are questioning whether we can turn the dual problems of drought and flood into a mutual solution. This is how ArcGIS got involved. Since 2011, farmers had been piloting with UC Davis and sustainable conservation, a practice called on-farm recharge. Then in 2016, key philanthropic foundations in California wanted to fund an innovative, cutting-edge pilot on the use of water data. The ArcGIS and sustainable conservation paired together and were selected as one of the pilots, where we built a decision support tool to scale recharge solutions. We used ArcGIS to build a GIS web app named GRAT, Groundwater Recharge Assessment Tool, working in collaboration with 2 California water districts. The most important thing we did up front was to listen. In fact, we spent more time listening to their problem statements than it actually took to build the tool and working with our fantastic software partner, Blue Raster. We asked what specific decision context did they want to better inform. Their main questions were the where, when, and how much of recharge. Above all, they said they wanted an investment tool, one that ensured as much water could be stored underground in the most cost-effective manner possible. So this is GRAT's high-level schematic. We essentially mimic district operations in the tool, from source water to field, done via true financial cost-benefit analysis that any CFO would love. Here is a quick 1.5-minute click-through of the tool. The user logs into GRAT. The tool has incorporated several dozen data sets, mixing both public and private sources, down to individual field scale. The user can enter an unlimited number of hydrologic scenarios, and then GRAT does an optimization. It finds solutions by creating a recharge portfolio utilizing multiple recharge types, such as on-farm recharge, across thousands of fields, accounting for variability on soil type and cropping, considering 5 different rain year types, 52 weeks a year, across 20 years, given existing conveyance infrastructure linked to individual fields, leading to a ranked list of best sites possible, with results incorporating all capital and operating costs for multiple recharge types so that they can make the best possible cost per acre-foot investment and incorporate that directly into their planning. It's important to note that our partner, Sustainable Conservation, had to create new science on crop compatibility to make this all possible. This optimization happens in the tool in a matter of seconds, with dynamic reporting so you can iterate continuously to find the best outcome possible. And other relevant data sets from the state and local governments are available, so all decisions are in context. Today, GRAT is being used by multiple irrigation districts to inform actual recharge decisions, leading to real-world outcomes in the Central Valley. And for an environmental nonprofit like ArcGIS this helps scale a nature-based solution that is helping restore California's floodplains through increased recharge. Today, the functionality is also being extended under the guidance of about a dozen water districts who see the potential of GRAT and are asking for further capabilities to be added. This version of GRAT is focused on an individual water agency. The larger scale question still remains. What if California could capture excess floodwaters on a complete watershed or state-level scale to recharge depleted aquifers, thus alleviating inevitable droughts? Doing this requires a tremendous, groundbreaking, integrated view of the water system throughout the state. This is California's moonshot, says Kamyar Gavechi, who leads California's integrated water resources management. But this concept, which is now being called FloodMar, is not fanciful thinking. It already happens today in California, but it needs to be scaled to the size of the problem. So today, DWR is leading a FloodMar R&D effort with 200 of the best water experts in California to turn this into scalable reality. What's unique is who's in the room together. Hydrologists, data scientists, engineers, and civil society, combined with people who manage floods, groundwater, surface water, ecosystems, and climate change. All different people who otherwise rarely talk. This is one simplified schematic that shows the key pieces needed for FloodMar. It requires integrating across the human and physical systems, combined with a financial and multi-benefit analysis that is essential for any solutions done at the scale of FloodMar. Work is now underway to pilot FloodMar as an integrated approach, combining over a dozen hydrological models in the Merced region of California. The work is being led by DWR and has an extended team of 20 individuals focused on climate change, reservoir operations, surface water, groundwater, and recharge. As you can imagine, GRAT is just one part of this larger system. To integrate GRAT, we adapted the district-level tool to ensure compatibility of model inputs and outputs across space and time. The work will provide a new long-term integrated view on water supply, flood risk, recharge feasibility, and groundwater effects that they've never had before. In looking at the two examples of individual GRAT and FloodMar, I wanted to highlight how they create spatial bookends, from local project all the way to watershed level. Importantly, we were just awarded funding by DWR to use the GRAT code to devise a new intermediate scale tool at the multi-agency sub-watershed level. This will be done in the Turlock area of California, across a dozen organizations, including multiple water districts and cities. It will bring together many water managers who have always wanted to collaborate more together. The goal? Find them opportunities where cooperation leads to better water outcomes for all, seeing a bigger system and helping them solve it. So across 3 integrated examples, we will be tackling this problem at all scales. Individual district, multi-district, and FloodMar. It's a true, coherent portfolio that unlocks new opportunities for more investments in improving water in the state. It's exciting to think about how the impact this approach could have if it were replicated across every watershed in California and one day the world. It helps provide a blueprint for how to tackle similar water challenges everywhere. Through this work, we have learned a lot. It has certainly required a lot of trial and error. If I had to boil this all down to one formula that has made this approach successful, it would be this. One simple equation, but one that you have to solve backwards. Not starting with data, but starting with the end user and a known decision that people already want to improve. In doing this, ArcGenome is playing a critical translating and connecting role, where we've aggregated dozens and dozens of data sets for each tool, then worked with partners and professors to create new applied science, while using technology and visualization to communicate the insights. But all driven by an important decision maker who has a big enough problem that makes this all worth doing. Access to decision makers is critical. It's one simple formula that's hard to execute. Particularly hard is the challenge of changing mindsets, especially as it relates to water. We need stakeholders to see beyond today's boundaries across both hydrological and ideological lines. Too often today, people only see what they want to see. This is especially true given how today is complex and interrelated. To make this all actionable, we need to elevate the complex to the simple. We need to empower everyone to see new relevant solutions that they didn't think were possible. In doing this work, we need to change today's paradigm about water data and tools. Specifically, we need to move from data visualization to decision-making, from risk to solutions, from static to dynamic, from single benefit to multi-benefit, from historic to future, enabling user-defined scenarios that don't just describe the past, but help shape a new future. But perhaps most importantly for ArcGenome's mission, from ad hoc to scale, thinking in advance how a single tool, quickly adapted and enlarged to work in a bigger system, can improve decision-making at multiple different levels, working across spatial scales to achieve scale environmental impact. Today, I think about water data and tools maybe 8 hours a day, often more than 5 days a week. I'm honored to play a small role in helping advance California's water data efforts along multiple fronts. I have crisscrossed California and other states like Texas and talked to dozens of water agencies. And I've been fortunate to talk about the future of water data tools recently at the World Bank's Water Week, which helps inform a more globally urgent perspective. I've done a lot of listening, and I'll never forget the golden rule of always trying to meet people where they're at. I'm excited to say that I see a new consciousness of what data can empower. There is a hope and optimism that a shared, integrated view is needed. More people want to see beyond silos, to connect and see in important relationships. However, we must do this in a way that engages all of society, especially the disadvantaged, making data more widely accessible and decision-making more visible across the entire community. Tools that enable transparency and inclusion, moving beyond big data to better outcomes via real change on the ground and giving people the right incentives to do so. Since we all know without motivation, nothing changes. Ultimately, solving environmental challenges comes down to people. Humanity must act. It all feels so intractable, but as a previous US president once said, if a problem cannot be solved, enlarge it. We need to define the problem to the size of the needed solution. And specific to water, that means water tools at all scales, a strategic coherence of tools that are acting at the best leverage points to change the whole system. Depth and breadth, with a dream and aspiration to help millions, if not billions, of lives. I would like to end this talk today by going back to the beginning of ArcGenome's journey. Back in 2014, the ArcGenome was thinking about how we should best structure our work for scale, impact. We had an in-person meeting here with Jack, here in Redlands, just down the hall. Among many gems of wisdom he provided, Jack said to me a phrase I'll never forget. Focus on information products that people will pay for. What I took away from that is the focus on adding value. People make decisions of real consequence today. If you give people a chance to make better decisions, they will, and it will be valued. But to do that really well, you need data and applied science and technology that make it all accessible to every decision maker. Since then, we have tried to use that inspiration to find ways to solve our greatest water challenges. And given we're an environmental nonprofit, we've tried to do that in a way that better connects humans and nature, and thus better appeals to our collective human nature. That's when tools are most successful, when it addresses human behavior at the fundamental level. So thank you to this entire community for all the work that you do at all scales, across water and so many other critical topics. We are all creators and innovators in a way that is grounded in felt needs, lives, and impact, speed and scale, done via diffuse innovation that is carefully designed at the local and global challenges that our world faces today, showing how inspiration and information are linked. I'm honored to be part of this community that will transform the world, and I'm filled with gratitude and appreciation for the work each of you do every day to address the world's greatest challenges. Thank you.